Let's talk about inequalities. But first, a history lesson. This is a light bulb. What does this have to do with inequalities? I am so glad you asked. You are so astute. You see, when Thomas Edison was working on the light bulb, he tried several experiments until he found the one that made the light up. Now, it's said that before he found the one solution that worked, he found 10,000 solutions that did not work. So using that as a springboard, we could say that an equality has only one solution, and an inequality has an infinite number of solutions. So for Thomas Edison's light bulb, the equality was the one solution that made the light bulb light up. And the inequalities are all of those 10,000 experiments that didn't work. Now, ever since we first learned numbers way back when, we've always looked for the answer to a problem. So for example, let's say we have 2 plus x equals 4. Well, that's a simple one, right? We know that x equals 2. That's the solution. That's the equality. So there's only one solution, but there's an infinite number of numbers that are not solutions. In other words, you could think of it as, well, sort of all of the wrong answers, the ones that don't equal. And we have special symbols for that, because if you think about it, if 2 is the only solution for this number, and you had to note all of the numbers that don't work, we'd need a whole lot of paper. So let's take a look at some things here. Let's say our problem said this. Let's say 2 plus x is less than 4. So how do we solve this thing? Okay, let's just solve it real quick first, and then I'll talk about how you note it on your paper. Here's the secret for solving these things. Ready? Treat the inequality sign, and there are 4, I'll talk about those in a minute, treat that as an equal sign when you solve these things. So, 2 plus x is less than 4. I'm going to treat it like equal sign. That was an equal sign. What I would do then is subtract 2 from both sides of this equation. And I would end up with x. Remember, treating that less than sign as an equal, as far as how we do our math, x is less than 2. Okay, now they want us to put this stuff on a number line. Let's go ahead and establish a 0 mark. And since it's 2 that we're trying to map, let's just go 3 places over. So 1, 2, 3. And we'll go 3 places to the negative as well. -1, -2, -3. Okay, so understanding that this says less than, put a circle around 2 on the number line, and then we draw an arrow going in the negative direction, or I'm sorry, a line going in the negative direction with an arrow. So this tells us that x is less than 2. Now, another way you might see this is with a little doodad underneath. And I purposely left it a different color. Normally it would be the same color. It's not a color specific thing. And what that means is less than now or equal to. So x could be less than 2, but it could also equal 2. So in that case, what you would do is draw a circle around the 2. But the difference is you would shade in the circle, you see. That means it could be 2 as well. 2 is included. And then you do the same thing. to recap, if we said x is less than 2, our number line would look like this. 0, 1, 2, 3. Usually I just go a couple numbers above and below, so that's why I went to 3. -1, -2, -3. Since the inclusion line is not included with our less than sign, we are simply going to draw a circle around the 2. We're not going to shade it in because it doesn't include 2, and we're going to draw our arrowhead going in the negative direction. Let me just highlight it real quick with a different color so you can see what's going on. I circled the 2. I drew a line going in the negative direction because it's less than, and I put an arrowhead. If our solution was x is less than or equal to 2, it would be almost the same. We got 0, 1, 2, 3. I realize I didn't put the tick marks in this example, but it doesn't really change anything. So over here we'll go -1, -2, and -3. So if x is less than 2 or equal to 2, in this case I would put a solid dot followed by our line heading in the negative direction to indicate less than. Again, let me highlight it for you. This is solid. Less than 2. I told you earlier that there were 4 possibilities with denoting our solutions. This is one of them, and this is another one. The other 2 are the inverse of those 2. Let me draw a line here so don't get confused. I'm just giving examples. In the case where x might be greater than 2, we would draw a number line. And so I'll go a couple above and a couple below. So I put a tick mark at the middle point, and I put 2 tick marks up and 2 tick marks down. So in this case, I'm going to start at the middle point with 2, 3, 4, and then I'll go 2, 1, 0. Okay? So 0, 1, 2, 3, 4. So x is greater than 2. So I'm going to put a circle around 2 because it doesn't include 2. And I'm going to go this time in the positive direction. So circle around the 2, line goes in the positive direction, arrowhead goes in the positive direction. This says x is greater than 2, but not equal to 2. 2 is not included. That's why there's only a circle around it. And the last possibility, as far as our inequality signs, would be this. I bet you can't guess. I bet you can guess, actually. X is greater than or equal to 2. And we'll do the exact same thing. There's only going to be one difference, and I bet you figured out what that is already. So we'll put 2, 3, 4, 1, and 0. This time we're going to solidify our marker on 2 because it does include 2. We have a solid dot on 2 on the number line, and our number line going in the positive direction. And that says x is greater than or equal to 2. All right, there will be more to follow. In the meantime, have fun with that. See you later.